Good afternoon, everyone. Welcome to a wonderful 2 p.m. lesson with teacher Jason here for a wonderful Sec 4 E-Math lesson. All right, some ground rules that we go through again, just a quick round up. Along the way, be patient and understanding. Observe gracious and respectful behavior, even in digital space. Just be careful of what you're typing. And lastly, for this particular lesson, please ask good and relevant questions. So, what are we learning today? Before we get to the starting of the lesson, just to clarify with regards to the question on 1B of the mock paper that we went through last week. Okay, so when we talk about rational numbers, right? Okay, not rational numbers, sorry, natural numbers, right? Okay, so in general, what happens when we say natural numbers is that they are positive integers. So include positive integers means excluding zero. So 1, 2, 3, 4, 5. Some mathematicians actually say that zero is a natural number. But we take note over here, when we talk about natural numbers, we follow the widely accepted definition, and zero is therefore not a natural number as what we have went through. So henceforth, when we actually talk about the mock paper question 1B over here, if we were to look at the general set, sorry for that, if we were to look at the general set over here, or the universal set, not general set, sorry about that, it should not include zero. So therefore, that's the universal set. So just a disclaimer over there before we go on to today's lesson, which is, okay, so matrices. So what are matrices? So what is a matrix? And the different kind of matrices we'll see. And we are going to face 3 different aspects of what we can do with matrices. So what happens when matrices are equal? What happens if we add or subtract them? Or what happens if we do a scalar multiplication? So what do we mean by scalar? We'll look at this soon. Now, when we talk about matrices over here, a few key things that we can take note of. So what is a matrix? A matrix, let's look at it, is in fact, if I form a rectangle and I put my numbers inside. Okay, so we'll call it a rectangular array of numbers. So that's what the matrix is. And if the number is inside the matrix, we say that there are elements. Okay, so if you were to look at the matrix over here, this is an example of a matrix where it is a little bit in the form of like a rectangle. Okay, and my numbers over here are elements. Now, what we are looking into a matrix over here is first thing, the order of the matrix. So how do we classify the order? In this case, the number of rows times the number of columns. Now, take note over here, when we talk about times over here, we are not evaluating the number. So, for example, in this case, what is the order of this matrix? So, we take note, how many rows are there? In this case, 2 rows. So, therefore, we write 2 multiplied by how many columns over here? 1, 2, 3. So, therefore, 3 columns. So therefore, the order of the matrix we say is 2 times 3. We don't say 6. It's not 6. It's just 2 times 3. Or how we were to say it's not times. This is actually mean 2 by 3. So the order of the matrix is 2 by 3. All right. So let's have an example, work example. So does anybody want to give it an answer? Or before I work this out, what would be the order of this particular matrix over here? What's the order of this matrix? Okay, does anybody want to give it a try before I go through? I'll just wait for a few seconds. So what is the order of this particular matrix over here? Okay, so let me just give some guides over here while you're working out. So we take note. Very good, Denise. Okay, that's the answer. But anybody else wants to try? Okay, so while I go through, take note. There are 2 rows, or in fact, yellow might be a bit light. Let me use green. There are 2 rows and 4 columns. So if I have to write this out, in this case, say 2 rows and 4 columns. Does anybody else wants to give it a try of what the order of this matrix is? All right, very good. Okay, I'm seeing a response over here. So we realize the order of this matrix is none other than 2 times 4. That's it. Don't say 8. The order is not 8. It's just 2 by 4. Okay, do not write 8. All right, but in this case, you don't have to color code. The color coding here is more of for me to make sure you understand. All right, now with this order of the matrix here, let's give it a shot. Time for us to try. What's the order of this matrix over here? Launching the bubble launcher, this one should be quite okay. It should only take you a little while to solve. Okay, launching the bubble launcher in 3. Okay, give me a while. Let me just relaunch this. Okay. Okay, give me a little while. My ask button is not there. All right, just give me a little while. All right, let me just do something. Okay. While you guys look at this particular notion over here, let me just do a little refresh because my ask button is not here. Okay, take a look at this question first. All right, let me just find out where I can source for my ask bubble. The bubble launcher is not launched yet, Isabel. I cannot find something over here. Just give me a little while I try to find out. Okay, launching the bubble launcher. Right now, I can find the ask button in 3, 2, 1. Let's go. All right, don't worry about it, moderator. Don't worry. All right, the bubble launcher is launched. Let's see your responses. Okay, it should be okay, right? Perfect. Over here, I still have 2 more people here to answer. So mainly, what we want to do, we want to find out what is the number of rows and number of columns. All right, doing good. All right, perfect over here. Okay, now I'll just wait the bubble launcher to slowly rise up. 3, 2, 1. Perfect. All of you all got it right. That's good. All right, so let's see how we have it here. So take note, this has 3 rows. And again, 4 columns here. 1, 2, 3, 4. So therefore, what happens? 3 rows. Sorry, let me color code nicely so that you're able to see. So I have 3 rows. And over here, next up, I have 4 columns. So bringing them together, 3 and 4, I'll just write 1 color. So it's 3 by 4. All right, so answer therefore is number 2. All right. This is, I would say, is pretty straightforward over here. So good job for everyone who got this down. All right. I would say, yes, there's a perfect score. Wow, that's good to see. Good to see. Okay, now let's move on a little to what we have next. So we have the different kind of matrices that we have over here. So the first one, if you take a look at this order of the matrix, can anybody tell me what's the order of this particular matrix here? Okay, in this case, you realize, again, let's review. I have 1 row, 3 column. So what will be the order of this matrix here? If you were to see it, I'll give you some time to type. Okay, 1 row, 3 column. Perfect. So realize 1 times 3 or 1 by 3. So 1 by 3. Now, why is this particular matrix interesting over here? Because you realize it only has 1 row. So if there is only 1 row over here, we call it a row matrix. All right, so just some special names that may come out in terms of when questions are asked. So row matrix, and in this case, if we have a row matrix, if I have another matrix, in this case, my order is of the form of 2 rows and 1 column. Does anybody want to fill in a keyword for me? What matrix do I call this? Give it a shot. In this case, the order, I hope you all know, is 2 times 1 or 2 by 1. What is this matrix do I call? Come, write down your responses. What do I call this particular matrix over here? Okay, I'll give you some time to write it out. What's the particular matrix? Very good, Ziying. Very good. Anybody else wants to try? All right, so the magic word came out already, but I'll give it like 5 more seconds for you to write it out. Okay, very good. Okay, I'm seeing the responses over here. The keyword is column. Okay, more special things can come up. Okay, what is this particular matrix over here? So if you realize already, I hope, this has 2 rows, 2 columns. So therefore, my order is then, I hope you realize, is 2 times 2 or 2 by 2. Okay, don't say times, 2 by 2. Okay, I'll fix with the word 2 by 2. So a matrix, in this case, if you realize, with the same number of rows and column, in this case, let's say if I have 3 by 3 or 4 by 4, and I can go on and on, but these are some examples, because if you realize, if I were to put them in equal rows and columns, it looks like a square. So therefore, we say that it is a square matrix. All right, so these are just different names that you need to take note of. And lastly, what happens is, okay, another kind of matrix that you can see is just like a number 0, we can say that doesn't matter what is the order of the matrix. If every entry here has 0, if all my entries here are 0, in this case, we have two names for it. Okay, just like your sets, we have called the empty set or null set, but of course we don't call it the empty matrix. We call it the 0 matrix or a null matrix. All right, so these are things that we take note of, or certain special matrix that we look at. Okay, now let's move on to one concept over here. Let's take note. If we want to say two matrices are then equal, following the concept of equal matrices, first things first, what do you think they have to have the same? What is that special word I add inside? Does anybody else wants to type it out and try? What is the special thing that matrices must have? Very good, Denise. That's actually correct. But let me bring it down to the floor. What is this special condition that I should have to show that they have this same particular notion? All right, let me just read a while. All right, very good. So you realize they should have the same order. That means the dimensions in this case. Same value, next one, very good. But in this case, we are talking about the next one, or the corresponding elements to follow up what Zing said. Same value, perfect. Or in this case, the corresponding elements are equal. So what do I mean? Suppose I have both 2 by 2 matrices and they are equal, which satisfies this first notion over here, same order. Both of them, the order is 2 by 2. All right. And if they are equal, okay, what has to satisfy is such that, okay, each of the corresponding elements are equal. So if I have to color code them, okay, A, W, B, X, C, Y, D, Z. If I were to say each of them are equal, the value we are talking about and the position is important as well. We say that A is equals to W, B is equals to X, C is equals to Y, and D is equals to Z. So these are the 4 things we talk about when we have equal matrices. And what are some examples that questions can come up when we talk about matrices being equal? Okay, so let's say these 2 matrices are equal. First thing, take note, they have to have the same order. In this case, both of them are 1 by 2, 1 by 2. Okay, perfect. So what we do, first thing, usually we write down the equations first. Or write down what is given. A equals to B. So equal to, write it down. Both matrices are equal. So we can write it this way. Now from here, how would I solve the question? Find the value of M and N. So can anybody tell me, based on this equation over here, how would I solve it? Write down your responses. Or in this case, if you can tell me the answer of M and N, let me know. Write down responses. I'll give it a while for you all to try. What will be the answers I have? Okay, give you some time. I'll give you all some hints. Remember, when I talk about the elements are equal, this over here, this element has to be equal to this particular element, and this one over here has to be this one. So when I color code them, I hope it is clear now what are the answers for, let's say, M. Let's talk about M first. What is the value of M in this case? I'll give you some time to think about it. Okay, now they have color coded very nicely. Very good, Ziying. How about the rest? Wants to give it a try? Okay, so Ziying has told me the correct answer. I'll just write down and perfect. Denise, following up the answer. What about why with the set sign over there, Denise? Okay, so you realize how I got it? Because the elements are equal. I have 4M equals to 8, and therefore M is equals to 2. And the other side, since they are equal, I have N over 2 equals to minus 3. Very good, Zing. I have N is equals to minus 6. A little bit of tongue twister over here. Okay, but I hope you guys got the notion of what it means for my matrices to be equal. Okay, because following up there are quite some bubble questions over here to do this. Equal matrices over here. So let's see. Bubble question number 2. All right, so let's see how we get this down. Launching the bubble launcher in 3, 2, 1. Let's go. Okay, very nice. All right, coming down, what is the value of S? All right, so identify correctly. What's the value of S? Okay, please take note. Don't cross read. Okay, some of you actually cross read. It's 2 by 2. Make sure the positions are the same. Last 10 seconds. Do not cross read. I think I know where I went wrong. Take note. Don't cross read. Okay, final 2 seconds. Okay, so most of y'all got it right, but some of y'all give me another option. So remember, position very important. Value of S. S is at the bottom right. So it should be at the bottom right as well. So therefore, S is equals to 8. Okay, that's the first part. S is equals to 8. Okay, some of you actually cross-read, but do take note. All right, be very careful. Do not cross-read the positions wrongly. All right, following up next, find the value of R. Okay, now find the value of R. Same thing over here. Please do not cross-read. All right, launching the bubble launcher in 3, 2, 1. Let's go. Again, please do not cross-read. Very important over here. Okay, it seems like you all guys are getting the trend already. Okay, find the value of R. What is R? Again, do not cross-read. Some of you actually cross-read the options. Take note, what is my position over here? If I have this one and this one, what is the answer? Okay, very good. Most of you all got it. Let's take a look. Okay, so take note. Again, don't cross-read. I have 2R is equals to 4. So 2R is equals to 4. Therefore, divide by 2R is equals to 2. That's why answer is number 1. All right, I think we have two more of the same notion over here. Bubble question number 4. Again, find the value of P. No worries, Lucas. Try to get it back. Bubble question number 4. I'm going to launch the bubble launcher in 3, 2, 1. Let's go. Okay, you still have a few more tries to get this down. So this is quite a bit of practice. All right, perfect. Okay, seems like most of you all got it down. Again, don't cross-read. If you don't cross-read, it will be a good sign over here. Again, most of your matrices, this is just an example. It can be of differing order. So this is just for 2 by 2. If the orders are different, the questions will be different as well. So we just take note. All right, 2, 1. Awesome. I think all of you all the answer got it right. Perfect. Okay, again, following the notion, find the value of P, 3P and minus 3. So therefore, I'm getting 3P equals to minus 3, P is equals to minus 1. Again, I think there's one more. Yes, following down, find the value of Q. Yep, that's right. Find the value of Q. Let's go. Launching the bubble launcher in 3, 2, 1. Let's go. All right, I think you guys are getting it. Very good. Let's see. Yes, I think in question 4 and question 5, I can see the affirmation there already. Okay, 15 more seconds. Okay, don't cross-read. I think some of you are cross-read. That's why you're giving me the answer. Or you're reading the wrong element. Take note, don't read the wrong element. All right, last 1 second. All right, so most of you got it down. Take note, when we talk about equal, again, the position, sorry for that, the position has to be equal. So minus Q and minus 9. So therefore, we have minus Q is equals to minus 9 and Q is equals to 9. All right, so take note, moral of the story, when we talk about equal elements over here, we talk about the position corresponding element. When we talk about element, the position has to be equal. In this case, if I'm talking about top left equals to top left. All right, the corresponding positions of the elements have to be equal. That's one thing to take note. All right, I hope equal matrices are quite clear over here. All right, very good, perfect. Now let's move on. Now, if we know what is order and they are equal, let's move on to how we perform our normal operations. So, when we talk about matrices, very, very important. If you want to add or subtract them, they first have to be of the same order. In this case, if they are of the same order, if we were to add them, we add the corresponding positions. So therefore, again, follow my color coding, very important, guys. So if I were to follow the color coding, B and X, C and Y, D and Z. Okay, If we were to follow the color coding, if I add two of them, what will I get? First one, I'll get A plus W, B plus X, C plus Y, D plus Z. Again, just adding the alphabets together. And similarly, if I were to subtract them, my corresponding elements in their positions will get subtracted as such. So this is what I will get if I were to subtract my elements together. Okay, so remember when we add them at the corresponding equal position. If we subtract them at the corresponding equal position. That's very important. Okay, so now with this concept over here, I hope you all got it right. And let's try a work example. Now take note, when the matrix is given in this way, please do not rewrite such that the row becomes column or the column becomes the row. Okay, or row becomes column or column becomes the row. Yeah, so basically don't rewrite the matrix, leave it as such. Okay, so what do I mean? When we want to evaluate this, right? Leave my matrices as such. Okay, 0, 4. Just write it down in this way. -3, 0, 7, 1, -1, 5. All right, do not, I repeat, do not rewrite my matrix as this. These are two totally different things. All right, do not write it like this. Okay, write it as it is, which I've written in black over here. All right, guys? Okay, so from here, what we do, if I were to add them, can anybody then tell me? I'll just test you all, see whether you guys are following. What will be the value of this particular position over here? So you might want to refresh your window again. All right, for the rest, I hope there's no lag. Okay, again, let me repeat. What will be the value of that particular position that I've shown in red? Does anybody want to give it a try? What is the answer over there? Very good, Zing. Perfect over there. What about the rest? Did we, anybody else wants to give it a try? Very good, Jesse. Perfect over here. Anybody else? I'll just wait for a few more seconds to gather some responses. All right, perfect. Okay, so I think most of you all get it. So what happens? Again, if I were to color code for that particular first element, I am just adding these two, which most of you all got me the correct answer. That's good. Very good, Fion. Fion, I think you might have done some manipulation wrongly. You want to check again? It's 1 plus minus 3. Okay, unless, yes, it's 1 plus minus 3, unless you might have typed the number wrongly. All right, so all right, yeah, that's right, Fion. So 1 plus minus 3, so just take note over there. Okay, and then we do it for the rest. So in this case, if we were to see it, 5 plus 1, 2 plus 0, minus 1 plus minus 1, 0 plus 7, and 4 plus 5. Following that, just do the operations as of their positions there. Or their positions there. So it's gonna be -2, sorry for the sudden earthquake, 6, 2, -2, 7, and 9. Okay, so just add them as of their positions. Okay, let me maybe write this a little bigger for everyone here to see. So in fact, just now it was 1 plus minus. Adding them according to their positions, you are going to get the corresponding answer. All right, so I hope this is good. Yes, doing perfect over there, but I understand it's hard for you to write down, but good job for listing all the elements for me. Good job. Now, with regards to this, let's have a bubble question for this. All right, so let's see how we can do it over here. Launching the bubble launcher again in 3, 2, 1. Let's go. Let's see what we have over here. All right, perfect. Okay, so remember, don't convert my elements. Just evaluate as what they are. Sorry for the highlighter. Evaluate as what they are. -2, 0, 1. 1 minus 3, 8. Minus. Now it's subtraction. It will still follow the same way. Let's see how you guys evaluate this. All right, very good. We have the last 30 seconds for those who have yet to respond. Just try to respond first. For those who have, good job over there. But take note, don't rewrite accordingly. Take note. Do not mix up my rules. Very important. Very, very important over here. All right. Oh, time's up. Okay, sorry for the lag. Yes. Okay, let's see the responses over here. All right, most of you all got it down. Very good. Okay, but let's see how we solve it again. Again, we are just, in this case, subtracting my elements over here. So minus 2, minus 3, 0, minus 1, 1 minus minus 2, 1 minus minus 4, minus 3 minus 0, and lastly, 8 minus 3. Again, evaluating each element over here, you are going to get -5, -1, 3, 5, minus 3, and 5. And this is the answer. That's why the answer is number 3. All right, for those who have answered some of them, okay, for number 2, you might have mixed up the rows, and number 1 and 4, you might have written as column instead of the rows. So remember, that's why I say just leave the matrix as such. Very important, leave the matrix as such. Now, one thing when they can come about adding, subtracting, and equal matrices can be questions as tedious as this. All right, so let's take a look at how we solve this kind of questions. It looks tedious, but let's focus first on simplifying this expression. So I have this chunky equation over here, matrix equation over here. How do we simplify further? So again, simplify as much as we can. Left-hand side, we can do some magic. So if we were to rewrite my left-hand side, I hope you all realize I have 3w minus w, 4 minus x minus 2y minus 1 minus minus 1, 0 minus 5y, 3x minus minus w. Okay, this is then equals to my right-hand side. Okay, simplify as much as we can. From there, what we do? We simplify even further on the left-hand side as much as we can. Simplify what we can simplify first. This is where, take note, when we want to find a value, in this case of linear equations over here, we try to simplify as much as we can first before we go on to solve. So the first part is what we have done, the addition and subtraction of matrices. And now we do as such. Now there are 6 elements over here, and you realize there are 4 variables. You'll be like, okay, I only learned simultaneous for 2 variables. How come there is 4? There must be some trick over here. Okay, no worries. We highlight the positions first before we go on to see how we can solve. Okay, again, positions, very important. That's the notion of equal matrices. Okay, in this case, I run out of ink. Let me see what color I can use. Okay, let's see. Oh, okay, I got gray. And I've got brown. Okay, making use of my colors here. So these are the positions over here. Zing, very good. You have got me the answer already. Very nice for W and X. Very nice. Now that's what I was about to ask, but Zing has given me the answer. But I'll now bring it out to the floor. How will I then find the values of W? Or if you know how you know the value, please write it down for me. So in this case, which value can I find first? And if you can find it, write down in your answer. I'll give it some time to let you guys understand how this works. But Zing, good job over there. Or for those who are confused with my question, let me repeat. What are the values we can find first? Based on this equation over here. What is the value we can find first based on the matrices that are equal over here? Or if you know the answer, you can write it down. I'll give you some time to think about it. Okay, I'll give you some time. Okay, give you some time to think about it, and very nice. So you realize what happens? If we look at linear equations over here, what we are familiar is if we have something with one variable equals to something in another variable. Or in fact, if both a variable equation with one variable equals to a number, or a variable with another variable where both of them are the same, it's easier to solve. So what do I mean? So if we were to focus in this case on the red color highlighter first, 2w equals to 4. We then say, oh, I can find w already. Very good, Zing. That's actually the answer. Perfect over there. Following up very nicely for me. Okay, so you realize we have w equals to 2 as such. Okay, good job, Zing. If you can get the answers, that means you understand this. I'll go through for the rest for everyone. So now we know w is equals to 2. Now with this, right, this actually helps us even better, because what we can do is we can actually solve even more for such equations over here. W, okay, W is over here. So what do we have next? Let's take a look. Okay, there's no W maybe except for the yellow color one or the blue color one. Let's see. So if we solve for the blue color one, 4 minus x is equals to 2w. Let's start with the value of w and see first. We have 4 minus x is equals to 4. Negative x, oh, I can solve it because this just gives this. Or if we focus on the yellow color one, 3x plus w equals to 2. 3x plus 2 is equals to 2. And it will still give me the same answer, which should be the case. Because if it doesn't give you the same answer, then somewhere in your working has to be wrong, so double check. Okay, now, what else can we do? We have the value of x. Which equation can I now use? The green color one. So we focus on the green color one. I have minus x minus 2y is equals to 10. X is equals to 0. Let's bring it in. So I have negative 2y is equals to 10. Y is equals to minus 5. And from there, I have y. What else I haven't solved yet? The gray color one. So I have negative 5y is equals to z. Negative 5 times, in this case, y is minus 5. Give me an equation there. So 5 times minus 5 equals to z. Sorry for that. Equals to z. Z is equals to 25. So these are where I get my answers. And how do I get them? First trick. Okay, let me write it down for you. Okay, try to find equations in this case. Try to find my equations in this case that are of just one variable involved. In this case, 2w equals to 4. There are just one variable involved. This is the key step, because if you can find one value, and if I sub in, and oh, it's my equations of just one variable involved either left-hand side, right-hand side, or both sides, I can manipulate them. Following up from here. So one variable, one variable, one variable, one variable at the end. All right, I hope I'm not blocking anything. And I hope you guys understand clear based on this tedious work example here. Okay, because if you understand this, again, let's bring it up a notch. Bubble question number 7. How do I find the value of x given this? 1 minute, launching the bubble launcher in 3, 2, 1. Let's go. Take some time. Again, try to simplify further with what we have. All right, very good. Most of you are getting it. Okay, give me some time. Remember, as we were solving this, you can actually write down your workings. So in this case, just write down my matrix first. Write down this first step. It's easier for you to see. All right, for the rest, if you have to try, give it a shot. Counting down, last 5, 4, 3, 2, 1. All right, excellent. Let's take a look. Perfect over here. Nice. Most of you got it. So let me just reiterate the working. Again, simplify my left-hand side. 3 plus 2, x plus y minus 1, 5 plus 4. Okay. This is equals to x 8 z 9. Again, I want to find x. Simplify my left hand side further. 5 x plus y minus 1, 9. This is equals to x 8 z 9. Now, I want to find the value of x. Which option gives it better? Top left corner. So therefore, in this case, x is equals to 5, and answer is then option number 2. All right, so that's the flow of one particular kind of question if they are equal. Okay, now following up a notch. Lucas, do you want to refresh your screen? All right, I think the rest is okay. Right, just let me know, moderator. If you can see me from the screen, just write it down. Refresh your screen accordingly. All right, what about the rest? Can you all see me? I hope you all can see me. All right. Okay, if you all can see me, just let me know. Otherwise, I will carry on. Okay. Now, next up, bubble question number 8. Find the value of y. That's a very good hint over here. Let's take note. Find the value of y. How do I do it? Okay, launching the bubble launcher. The previous working should help you. In 3, in 2, in 1, and let's go. Okay, this will help a bit. All right, last 40 seconds. Lucas, you might want to try to restart your software a little bit. I hope that will help. Okay, but don't worry, the main concepts are just as such, so do not worry about that. Last 30. All right, I hope you guys realize that this is just a continuation from the workings that we have. Last 20 seconds. All right, you guys are doing so good. Perfect. All right. Okay, last 10 seconds. Counting down in 5 seconds. 3, 2, 1. Perfect job. Let's take a look over here. All right, awesome. Most of you all got it, except for some. Just make sure that you're reading the options correctly. So you realize why I gave the value of x. There's a hint over here. From your previous working, I hope you'll just continue from there. Please do not try to reset what we have. So we have 5. Sorry for that. Is x 8 z 9. So I hope you'll realize to find the value of y, I am going to have to compare this. Okay, because with this option, I can say x plus y is equals to 8. Knowing the value of y, I mean x. Yes, knowing the value of x. Sorry about that. I can say 5 plus y is equals to 8. Henceforth, y is equals to 3. Henceforth, option number 4 is correct. All right, so that's how we compare and making the equations now. Okay, next up, following up, I have y is equals to 3. How do I solve for my value of z? All right, now let's launch the bubble launcher. Launching now in 3, 2, 1, and let's go. All right, doing good. Doing good over here. Counting down to my last 40 seconds. Last 20, all right. Very good job to everyone here who has gotten the answer. Perfect over here. For the rest, give it a shot. Again, we are just making use of the different kinds of elements that we have. Basically on their positions. Launching now in 3, 2, 1. Time is up. All right, so let's take a look. Okay, so let's see. Now, again, this is finding the different parts. So what we have, again, making use of our equation just now. 5 is equals to x plus y y minus 1, 9. This is equals to as such. Now we know from A and B, these are the values that we have. I'm not going to ask you to memorize the values that we have. Which equation here can we use? Now let me bring it down to the floor in this case, since most of you all got it. Okay, suppose I name this position 1, position 2, 3, 4 to test everyone here to make sure that you guys are getting it instead of just guessing the answer. Can you tell me which of the two options I have should be equals to when I solve that? Which should be equals to which when I solve for the answer? Okay, glad to hear that, Lucas. Now let me just bring down to the question. Given the equations are labeled as 1, 2, 3, 4, 5, 6, 7, 8 accordingly, for those who have answered the bubble question, you all should know the answer. Very good, Denise. That's what I'm asking for. That's perfect. And let me bring it down to the rest. Which equations should be equals to each other when I solve for them? Let me bring it down to the floor to make sure I get a clear understanding from everyone here. I mean, clear. Yeah, you all can still see my hands clear here. All right, let me bring it down to the floor. Which equations am I looking for when I find the values of z? I'll give you some time to think about it. Okay, so I believe you all got it already. Very good. I'm seeing the question. Nope, Lucas. I still have one more. I think I think I have one more. All right, there's still one more. All right, so stay tuned for it. And yes, following Denise' answer, perfect over here. Equation 3 equals to equation 7. And this is how you make use of values to solve for the answer. Because I know y is equals to 3, so 3 minus 1 equals to z, and z is equals to 2. Not yet, Lucas. Not yet. I'm going through this answer because this is already done. Option number 1 is the answer. All right, so this is for bubble question number 9. I hope you all get how certain questions are mixed when we talk about addition, subtraction involving algebra, and in fact, what happens, they're equal. There's one particular way whereby they can ask you to solve for matrices question. Now, there is just one more concept we have to learn through, and they can actually involve scalar multiplication of matrix. Now, then you may wonder, what does it mean to be a scalar? Like, what is scalar multiplication? Isn't it just multiplication of matrices? Are there different kind of multiplication? In fact, in matrices, yes, there are different kind of multiplications involved. Today, we'll go through scalar. Next week lesson, we will actually go through what it means to multiply matrices together. So for today, it's an easier way to see. We are multiplying scalar first. Next week, you will have an understanding of what it means to multiply by two matrices multiplying together. Looking into that, what does it mean for a scalar multiplication of matrices? Scalar over here, you can think about it, is just a number over there. A very nice number, in this case, a constant. The scalar k over here, we say is a constant. Now, what does it mean when a matrix A is multiplied by a scalar k? Very simple notion here. If it's multiplied by a constant k, every single element in my matrix over here is multiplied by this particular constant k over here I'm looking at. Which means if A is this particular question over here or particular element over here, then k of A is just none other than, if I have to write an intermediate step, A, B, C, D, this particular element k over here is multiplied throughout for each particular element over here. What does it mean? Have this picture in your mind, thinking about k distributing to each of the elements there. Essentially, you are just going to get, sorry for that, none other than Ka, Kb, Kc, and Kd, respectively. So this is the notion of scalar multiplication. Scalar means just a constant, bringing to each of the elements over there and forth. Okay, now, what is an example of a particular question that can come about? Let's try something simple. What happens when I have something like this? So in fact, it's what we have been going through just now from the previous work example. Just that right now, when we talk about these matrices over here, there is a constant outside. So a scalar outside to be more exact. Now, if I want to evaluate this, let's take a look. Firstly, before I evaluate this, let's see whether you understand scalar multiplication. What are the entries written in the order that I want for this particular matrix I look at? So if I have this, I want to get my new matrix for the red color box. What are the entries I should have? I'll give you some time to write all the entries possible. What are the entries I should have for this particular matrix over here? Give you some time to think about it. Very good, Zing. Okay, that's nice. Yeah, okay. I think one of them is a little error. All of them are almost correct. Just one element you have missed out, Zing. Take a close look, and I hope you know which element I'm talking about. Because remember, when I talk about scalar multiplication, each of them has to get distributed equally over here. Yes, I think you realize which one is it already. So let me just write down the answer. This one is going to be 2, 4, minus 2, 6, 0, and minus 8. All right, this is the last one you have missed out. And to make sure maybe to get some redemption on your side, for the blue color one, maybe let everyone else try. If I matrix multiply, what is the matrix that I'm going to get? I'll give you some time to write the answer. I'll give you some time to think about it. What is the matrix that I will get? Okay, let me check the entries. Very good, Sing. Okay, that is nice. Okay, but I take note in the exam, please write in the certain order. Don't write them in the row matrix. But I understand it's hard to write the matrix in the bubble questions. It's hard to type out. But yeah, I get what you mean. Perfect over here. Let me bring it out to the floor maybe for a minute to let everyone else try. For the blue color box, what are the entries I will get? Remember again, following the same focus that I have to multiply for, let me see what color should I use. Yeah, let me just use green. When I scalar multiply, when I bring it to the rest of the entries over here, what will I get? Okay, but I think you guys are getting it. So if I were to bring them all inside, I'm going to have negative 3, 0, 0, 6, 3, and 9. So this is what I will get. And from there, it is what we have touched on just now. How do we add, in this case, for these two different matrices over here? So therefore, this is to add them, and adding them, add them respectively. 2 plus minus 3, minus 1, 4 plus 0, 4, minus 2 plus 0, minus 2, 6 plus 6 is 12, 0 plus 3 is 3, minus 8 plus 9, it's 1. Okay, so in terms of scalar multiplication, we have to do the scalar first before we add. Similar to how we do for equations, just that now we branch it out to matrices. All right, I hope this is okay for everyone over here, because with this will be the last bubble question for today. So I hope you guys are getting it. Launching the bubble launcher in 3, in 2, in 1, and let's go. All right, give it some time. Remember to do your matrix multiplication first. No, sorry, scalar multiplication of matrices first. Take note, okay? The wordings over here are very important. Okay, remember, first things first, I need to write down, if it's easier to see how my matrices work. Always write down the equation first. It will be easier to take note. From there, what will I have? All right, last 50 seconds. Take your time. For those who are trying to attempt this, don't worry about it. some time, take the time to ease into what we solve. Okay, remember, this is just a follow-up from the concept that we have and the positions. Take note. Very good question. How to not get confused with normal expansion. When you talk about normal expansion, Denise, is always an equation. So x plus y. So if you, in the form of matrices, you realize in between two particular numbers, there isn't really an operation to begin with. So in this case, for this particular example to go through, finishing up the bubble question, that is good. Yeah, this is very similar to BODMAS. So scalar multiplication, it applies to BODMAS as well. First thing, this is how the brackets, we expand them. But in this case, to reiterate what Denise said, when we talk about matrices, if you realize for matrices, the numbers are usually spread out a bit more to tell you, hey, these two numbers are separate numbers. Please do not add them together. In this case, scalar multiplying, I'm getting 3 minus 6 minus 0 minus 4 plus 6 and 2. All right, so this is the notion. When we talk about matrices, usually the numbers are more spread out. They will not put the numbers very closely together. So for example, like this. This is not a matrix because they are close together. Okay, this is not the matrix I'm looking at. Okay, this is not the matrix I'm looking at. When I look at a matrix over here, the numbers firstly, they are spread out even more. Then what happens? We expand them in. Okay, so this is the notion of what we are doing when we are doing scalar multiplication. Now the arrows look like I'm doing a normal expansion, but take note, I'm just saying that the number get distributed like this. Please do not add them together. Okay, they are spaced out much more over here. Okay, once we have this, that's where we add them into their corresponding positions. 3, 0, 6, minus 6, minus 4, and 2. From here, what we can do, step by step, if you cannot do it straight away. So what I mean, 3 minus 0 gives 3, minus 6 minus 4 gives minus 2, and you leave the third one over here. And after that, following the same position, following the same color coding, 3, 6, minus 2, and 2, same position again. Sorry for that. Let me do it again. Sorry for the notion over here. Okay, this is equals to 3 plus 6. This is 9 minus 2 plus 2. This is 0. So this gives me the answer over here. So I hope this clarifies on the BODMAS and the normal expansion and not to get confused between them, Denise. And this is what we have for this bubble question. All right, so in fact, that is it for today. Yeah, today's lesson, I hope it's not too heavy on you all. So what we have touched on, so we have learned over here what is a matrix and the different kind of matrices we see. Lastly, what's an equal matrix, addition and subtraction of matrices, and lastly, what is a scalar multiplication of matrices that is involved. All right, so for that is it for today. If there are any questions, feel free to stay on. I'll be more than happy to answer any of your queries. If not, this is Teacher Jason here, signing off, and I'll see you all next week, same time. Take care. Bye-bye.